All right, so of course we're in advanced C++, and I'm pretty sure all of you have had some C++. If you have not ever coded in C++, you want to talk to me after. It's going to be a little bit of a tough challenge for you to kind of take on this class if you've not been coding in C++, or even if you haven't done it lately. So we'll try to do some review. The first couple lectures are about like a kind of a a blitzkrieg review of things that we covered in Intro C++. And everybody needs one. I need one too. So that's time well spent. But then we're gonna build stuff. We're gonna build big stuff, and we're gonna learn new things. So if you're gonna try to catch up and you're kind of behind on your C++, definitely you're gonna find that to be a little bit challenging. I'll try to work with you on it, but let's talk after if you're coming in completely unfamiliar with C++. So anyway, a little bit about me. Most of you guys know me. I kind of come in from the software industry. I love coding. I do code every day. I kind of jump around in different languages depending on the need. Try not to keep things in my head because we have the internet. But eventually, if you code enough, things kind of stick. My introduction was through kind of engineering, graphics, and interactive 3D graphics. So ended up being games and special effects, but a lot of math, right? And a lot of late nights working on code. Today we have a lot cooler tools, a lot cooler tools. So it's even more fun than it ever was to code. I really appreciate being able to teach you guys. I try to treat my class like a product. So if you have any feedback, you guys know I need feedback. I want to know if I got something, kind of if you're misunderstanding or I missed something. So thanks for that in advance. Never feel bad pointing out something I got wrong because I need to fix it for everybody else's benefit. So thank you for that in advance. Just a reminder about Wi-Fi. If you had a certificate, I don't know if these things still work the same way, but it seems like every year the first week your certificate from last year goes bad and suddenly your laptop stopped working. So don't forget about this BYOD.marin.edu. If you got to go refresh your certificate or your password or get a new device signed up, that's where you're going to start. And then you'll be able to use our regular COM Wi-Fi. So if you kind of hang out on guest Wi-Fi, it's going to be really slow. So you want to get signed up over here and eventually get onto COM Wi-Fi so you got faster access for that stuff. So let's just go around real quick. I'm not going to make everybody kind of tell me a funny story, although I'm always interested. So if you want to share, but I would like to know if you have any games like actual physical board games or any kind of puzzle games or anything you like. Don't feel bad if you don't have any, but we're going to try to put together some kind of a collaborative thing. I always try to put something together like this. It's a little messy, but we're going to see if we can make it happen. Last year, we tried to make Settlers of Catan. That was a pretty wild time. We'll see if we can kind of do that. We were probably overreaching on that one. But tell you what I want to do is just let's go around. I'm going to go from the back corner here. We'll just sort of arc around the whole side, outside in clockwise fashion, and then we'll come across front row, back row. So when we start, just say your name, and if you got anything you want to share, just throw it out there for us.
Yeah, hello, my name is Pierre. Yeah, I look forward to having class with all you guys.
Cool. Welcome.
I'm Richie, and maybe trying to make like chess would be fun. I don't know.
Cool. Very good. All right.
I'm Daniel, and I also think chess would be pretty good.
Excellent. Excellent.
I'm Gabe. Only transferring this year as computer science.
Right on.
Noah, chess is
Awesome. Very good.
I mean, immediately shot down my Catan idea.
Oh, well, I haven't ruled it out entirely. We learned a lot from last year, so it's a good game to build, actually. Awesome. Welcome, Andy.
I'm Lucas, and I think BS would be good.
BS. Oh, okay. Yeah, I have to look back into that one.
Hello, I'm Arash. I'm this year. This is
Very good. Welcome.
Brett, I think maybe we have Risk.
Risk. That's a good one. Very good.
Pretty awesome, and I think also an operator chess.
Okay. Excellent. Very good.
Name's Eric.
Yeah, I think Risk would be cool.
Risk, good one. Yeah.
My name's Calvin. I think Scrabble.
Scrabble, great. I like that one. Very good. Let's go to the front row, left corner.
Thanks, Kyle.
Scrabble, good stuff.
My name's Adrian, and I like Risk.
Awesome.
Thanks, Dalgo.
Risk.
Risk, very good. Yeah, a lot of Risk players.
My name's Ricky, and I think Risk would be good.
Very good. And back left corner, Mason.
My name is Mason. I also think Risk would be cool.
Great.
Kevin, majoring in computer science, and I do a lot.
Right here. Welcome back, Kevin.
And, Moncala.
Mancala, actually good. I love that one, actually. I love simulating Mancala, actually, too. So awesome. Well, thank you for those suggestions. I have an opportunity to kind of put some stuff in a discussion. It's not a graded discussion, but sometimes I just forget the stuff and take notes. But I heard a lot. I Risk, Monopoly, Scrabble. Those are really good suggestions. Hey, Sebastian. So good stuff. We'll see if we can put that together. Thank you for sharing a little bit about yourself. So let's kind of dive in. I'll just sort of go over stuff most of you know, but a little different for this class. So I think of you guys as the kind of upperclassmen in computer science. Many of you have been in one or multiple classes with me, so I expect a little bit more from you. So it's kind of like next level stuff. I hope you're curious. Most of you are and are doing like little research on the side about stuff. I often see that in your code over the years since many of you have taken multiple classes from me. So we're going to do a concerted review of Comp 130. You're not going to remember all of it. That's okay. We're not supposed to be books where we memorize all this stuff, but we're going to try to get you up to speed pretty quickly. So our first quiz, which is due in 2 weeks, is kind of like a mini final exam from Comp 130. So don't let it terrify you because it's a really small part of your grade. But if you like really struggle with that, go back and take it again, and then go back and take it again, right? So you got 3 tries like we always do in my classes. So it'll hopefully help you get caught up a little bit, especially if you've been away from the code for a while. Take a glance at the syllabus. Probably you're pretty familiar with how I do my classes. And let me know if you have any questions about Canvas. I assume that most of you know your way around, but if you don't, I won't spend a lot of time on it now because most of us know that pretty well. And we're moving away from Replit. We'll talk about that here in a little bit. I know it's been kind of bumpy. It's not that it's a bad platform. It's just gotten to be too expensive to use for school. So for those of you who are using it and are paying for it, please plan on keep using it. I use it at home. I just want this to be a free class and I don't want people to have to pay for their software access. So we'll have a couple options you can choose from. We'll talk about that here in a little bit. So Replit's still fine, but I'm going to try to be moving my content to a different kind of a platform. So again, keep researching, and that really includes AI. We'll talk about that a little bit. AI is just so amazing. It's scary and wonderful at the same time. If you're paying attention to it, you kind of know what I'm talking about. But in terms of coding especially, many of you might realize that it probably is smarter than all of us in this room at this point, right? It's pretty amazing. But we still got to train our brains. And so, you want to challenge yourself in this class so that you know how to kind of control AI rather than the other way around. So if you have troubles, you're getting lost, let me know. Don't wait too long. And of course, please don't make me remind you to do your own work. You're kind of more advanced students. I assume you know that you're here to challenge yourself. If you're falling behind, you're panicking, just let me know. I will help you. Just try not to take the shortcut because it's just unfair to other students if that becomes your main way of getting through the class, okay? Now, the big thing, and I'll remind you about a couple of things that become pet peeves for me at this level. It's like if I give you a prototype on a function, like it's got these inputs, it's got these outputs, it's got these data types, you should not be changing the prototypes. Or if you've got an improvement, talk to me first, but don't just go changing that stuff because that's how we sort of establish the blueprints for your homework and your labs and stuff. Also, try to keep your code clean. That goes without saying. Pretty much your grade on every assignment now will kind of in part be, can I read your code? So if you're throwing stuff over the wall and I can't read it, I might knock off a few points. And of course, test your code. make sure that it works. Be your own worst enemy on your code if you've got the time. I know sometimes we run out of time, but testing is part of writing code. So you should be starting to think like real software developers at this point. So please keep that in mind. And you don't have to be really, insanely, rigorous about it. We can assume that our human users are going to kind of more or less follow our instructions. But, generally speaking, you want to test your code reasonably well. So in this course, we're going to reinforce what we already know, and we're going to push our understanding, not just about things that are specific to C++, but all languages will be using the things that we're learning about. We're going to learn about them in C++, but these are advanced patterns, or sometimes I call them constructs, where we can imagine these ideas or patterns in our head and then go apply them in C++. So they're really all about how to communicate with computers in a more powerful way and customize what languages can do. So we'll be studying those and making larger programs. So we're going to be doing a lot of multi-file programs in this class. And in C++ in particular, that is a little challenging. It is not the most elegant language yet for working in multiple files, but it is exceedingly rigorous and it is very widely adopted by large-scale software development groups. And so we'll see how they do it. And you might at first think it's a little tedious, but that's kind of how it works. And it's evolving like everything. But prototypes are the crucial way in which we all agree how our pieces of the puzzle are going to work together. So if we were to do Settlers of Catan and someone was going to work on, the robber and someone else was going to work on the hex, the terrain parts, we got to agree ahead of time how all these things are going to communicate with each other. And so we typically write down the prototypes or the functions or the classes and how they're going to work ahead of time, and then we start coding. And the prototype part we think of as the .h files, which we'll learn about in this course. And the .cpp, of course, is not just main.cpp, but it could be any CPP that's related to some C++ class. So we'll be doing a lot of object-oriented design in this class. We'll be trying to break down every problem we think about into a C++ class. So if I looked at this room, I see computers, I see chairs, I see humans, I see lights, I see C++ classes everywhere I look, right? So we're going to start trying to think more that way as programmers. And we're going to apply some relatively advanced features called polymorphism that allow us as programmers to kind of pass on hereditary information through a class hierarchy. So let's say we create something called a game character. Well, what kind? I don't know, but every game character has a lifespan, right? So now we can inherit those characteristics and create subclasses from that. So a lot of features that we're going to explore have to deal with inheritance of classes that are dependent on other classes. And many, many advanced software development projects build themselves that way. They think about what is my base class, and then what inherits from that, and what inherits from that. So it's a whole other kind of hierarchy we haven't really even talked about in some of our other classes. So hopefully you'll kind of catch on to that as we go. And we'll just try to do a lot of coding so that you get better, because like anything, we just got to practice. So those are kind of our high points. As many of you know, we've got a pretty standard structure for my class, 2 labs a week, a quiz and a homework every 2 weeks. Our stuff is due either on Friday at midnight or on Tuesday every other week at midnight. So I'm going to try to have fewer links in my slides because it's kind of gotten so messy. But please go find your links for these things in Canvas. They should be available to you now. If you need to get to them, and you can jump in right away. You don't need any information that you don't already know to finish labs 1 and 2 and homework 1 and quiz 1. We will review to help you, but for those of you who want to kind of get a jump on things, you can go after that stuff right away. You do not necessarily need to wait. So, and these are easier, I would say easy, but easier points than some of the stuff down the road. So try to, if you got time now, go after that thing and sort of get a little bit of a jump on that. Now, so typical way I structure things, we've got our welcome module. This is like what we're talking about now. So you can always go back and read it or watch the video for this thing. That's in our home section. And then, I won't go through all these things, but that's stuff we're talking about today. So all the reference information is there or on your syllabus page, if you can kind of go find that. For our quizzes, if you haven't done this today, so our quizzes are in, of course, the quiz section, but also our attendance survey is down here at the bottom in the survey section. It's really easy. It's very forgiving. You just got to click on it and then type in the number of the lecture that you're seeing today. Okay, so today is 1. So you do that while you're here. Can't really do it when you're not here. So appreciate it if you kind of do this while you're here. If you forget, not the end of the world, come back and do it next time. But obviously, if you're not able to come to class for, 3 weeks, I got to let you go. And this will be our kind of evidence of, you haven't been able to be here. So please keep that in mind. I'll remind you every day. And thank you for doing it. I know it's kind of a nuisance. So every day and every week rather is structured kind of, as you know, we got 2 lectures a week. And so we'll have some a PowerPoint, and then we'll have a lab, and then I'll tuck a little video underneath that, and then we'll have some practice problems kind of sprinkled in there, right? So at the end of that 2-week period, we'll have these quizzes and these homework assignments. So that's kind of the structure we'll see over and over again. Now, I know that a lot of our practice problems in Canvas are based on RepoLit. I've literally got like 500 practice problems I'm converting. So bear with me. I'll try to, get these things converted so you don't necessarily have to have a Replit account. Worst case, you can copy the code out for free and move it over to some other platform. But please bear with me as I kind of convert myself over. But as a minimum, like take a look at these review things like loops, strings, C strings, using namespace. Like you can glance at this and know right away what I want you to know, right? If you know what those things mean, you're in great shape, right? So that's a lot of review material, but that's really kind of the stuff I'm hoping everybody kind of has a little bit of a sense of, okay? So that's kind of a lot, but we're going to kind of punch through that in the next 2 or 3 lectures and then start doing new stuff. So it's all there for you to come back to whenever you get a chance to kind of look at it. And if you know it, then don't sweat it too much, right? You'll just have to kind of work it out in your homework assignments. So too much stuff to review. So I have lectures, what I call 2B and 2C. I will have videos available for you to kind of go back and review kind of the nitty gritty C++ stuff. None of us want to go back and relitigate all of Comp 130. So, but I have it there for you in a more condensed place if you need it. And I will always reintroduce stuff right before we use it. So, but things like pointers, you might find a little challenging, right? So you might want to be proactive about those. But in general, you'll see stuff at least twice throughout this semester. So in terms of review, so you'll get a second chance to kind of review it before you have to use it. AI, most of you know where I stand on that. Use it wisely, right? So our exams are open book. But closed to AI, just like they would be closed to consulting with your friends, right? So you can use the internet. I realize the line is getting blurrier between AI and searching on Google. So just try to do the right thing. You kind of know when you're in danger zone when AI is writing code, you don't know what it means, right? So you definitely want to stay away from that on these exams. If you are researching something, just like researching on the internet, use AI, man. I use Google search, of course, and I have conversations with ChatGPT all the time. It cracks me up. I will discuss things with it if I'm trying to fix my car, over the Christmas break, and I don't know how to fix a car. I'll be like, hey, it's kind of idling rough. What could that be? I just think that's a great way to learn, right? So I hope everybody's thinking about that because this is, of course, never going away. And AI, if you don't know, understands code better than anything. But the only other thing AI probably understands better than code is legal contracts because of the structure. it gives it fantastic resourcing to know how to build something that matches what it thinks we want. So it's really not going to go away. And of course, there's a lot of discussion about how this is going to affect our lives as software engineers, but we want to understand as much as possible so we can tell it what to do, not the other way around. Okay. So, but please do not have it do your homework for you. There's no point, obviously, in doing that if you want to learn stuff. Okay. And I'll have to give you 0 if you end up doing that. So please try to stay out of that particular trap. And in general, if I see, people copying code from each other, that's just not cool. I think many of you know how I feel about that. Most four-year universities, if you're going on to a CS degree, are very rough on you if they find out you've been doing that. They really want you to write your own code. We'll talk about in a second, like how you avoid that problem, but, discuss things with your peers or with tutors or draw things on the whiteboard, but copying code or, trolling somebody else's code, it's just not a good idea. Okay. So please try to avoid that. I know maybe other teachers don't treat it that way, but this is how most CS classes treat homework. So please be aware of that. Okay. This is kind of how I like to use ChatGPT. It's like, hey, I forgot how to use pointers. Can you tell me, right? So you can kind of click into this link if you want to see an example conversation that I think is perfectly fine, right? It's like, well, why is it that way, right? So I know you guys probably know pointers, but we'll be doing some more advanced stuff. So feel free to have that conversation. It's kind of like having an expert coder on your side. You just don't want to say, hey, I need this by 8 o'clock. I got to transpose a 2D array of numbers, right? So I know it's tempting, but in the context of a class, we want to avoid that. Okay. If you want to collaborate, that's totally cool, right? Away from the keyboard, on a whiteboard, talking to your friends, on labs in particular. So if you see somebody next to you that's struggling with a lab, that's cool, man. We're trying to learn. But homework and quizzes and exams, of course, are different things. So feel free to do that kind of stuff, especially if you're away from the keyboard. That is okay, right? So if you are using a tutor, tutors know kind of how to use the Socratic method a little more. They're going to try to challenge you, and I'm okay with our tutors and how they help. So you can get a little more help from your tutors if you get stuck on this stuff, because some of the syntax that we're going to go through is a little challenging. Okay. We're going to try, I always say we're going to do this, we're going to try again, we're going to try a group project. This is going to be kind of crazy, but it's going to be very real world. Here's how it's going to go. We are going to start with a project we're going to work on over the course of maybe most of the semester. And you're going to start some code, and we're going to work in separate teams. And then you're going to move to a different team, like you're moving to a different company. And so you're going to have to start working with somebody else's idea about how to solve that code. And you're going to have to leave your code behind. So what we want to develop is kind of a real world understanding of, quite honestly, what it's like to be in a software company. It's like you don't really always get to have a blank piece of paper. So you learn to appreciate good structured code, comments, that kind of thing. And you also learn when you see some like people doing some total ninja fancy stuff. You're like, whoa, what is that? I would never would have thought of doing that. And you learn something, right? So I'm going to try to set this up with groups, and we're going to try to tackle a manageable problem. But the most important thing we're going to learn is like what it's like to like be parachuted into somebody else's code and have to take it to the next level. Because that's really what it's like to be a software engineer out in the real world. It's just, you kind of got to work with what people actually create. So we'll have opportunity to talk about stuff and, think about how we're going to approach this stuff. And hopefully everyone's teams are all kind of equally contributing so nobody feels kind of left out. But I'll let you know here pretty quickly what kind of project we're going to work on. So and this is kind of one of the few times where I want people to be very open about discussing and sharing ideas and code. So this is one homework we'll want to collaborate on. So I'll let you know more about that soon. I think everybody knows about attendance. Please try to show up semi-regularly. I know we all have challenges. If you're gone for more than half the time over a 6 lecture period, I will give you one warning and then I have to drop you. So please don't forget about that. And unfortunately, there's a class in here beforehand, so we got to have office hours up in my office for this class. So if you're looking for me, I have office hours right before this, but I will always try to make myself available. Just let me know if you need some time and we'll try to put something together. We can always do it on Zoom as well. Okay. It's not a online class, as you know. I can't let you just be virtual. So if you're not around, I will have to drop you. But you do not have to come to the labs, right? So everybody knows that. If you think you got it handled and you don't need any help from your peers or myself, then feel free to go on to do what you need to do. Just get your labs in by midnight on Friday, and we should be all in pretty good shape. Midterm, as always, is a required attendance day. I'll remind you about that. Same with the final exam. So that is in class. I think everybody knows that by now. And I will try to remind you of all those times so you don't forget. Okay. So we talked about this already. So just please remember that. So, you know, you kind of don't have to think about it. Once you get in here, just knock it out and you'll be done. Okay. Resources for this class. So of course, Canvas, we are going to, so we've been gifted about 100 licenses of Program IZ Pro. So for those of you who were in algorithms last year or C++ and Python, it's been a little bit bumpy. I still love Replit, but it's just too expensive. If you have it, keep it. I will support you. If you want to use Visual Studio Code, please keep using it. I will support you. Program IZ is a little bit of a young version of Replit, but they are working on some interesting stuff. I'll show you here in a second. And I think it could be a good experience for you because you will be beta testers for a brand new product that is being developed professionally. I was on the phone yesterday with the folks in Kathmandu in Nepal, and they said, you know, can your class be testers for us? And I said, yes, I think we can do that. It is optional, but if you want to do this, just respond to my email in Canvas and say, yes, sign me up, and I will sign you up. You don't have to do anything else. If you've already signed up for Pro, don't worry. It will sort of elevate your permissions level, and you'll have access to a lot more stuff. So you don't have to do it, totally optional, but my hope is that it will kind of make your experience a little easier. Obviously, there's lots of other stuff out there. We're going to be exploring a lot more content, and a lot of it goes beyond W3 schools, for example. So we'll see a lot of new stuff that is in, let's say, Program IZ, but we're going to have to get a little bit better at reading some of this dense material. This CPP reference is a little hard to process sometimes. We're going to have to look in there. This is an excellent kind of middle tier thing. If you ever get lost and you just go read up on some stuff, that's free. So I'll remind you of those things as we go through the course and the code. So Replit is still okay again, but Program IZ is going to be hopefully a little easier for you. Okay, so I think everybody's kind of familiar with this part. I won't go through this too much in detail, but we'll have a lot of coding examples and the assignment links will be in Canvas. We have a book if you want it. This is an excellent reference book. It's very heavy. It's not fun to carry around, so I haven't looked at it in a couple of months because I just look stuff up on the internet. So that is quite optional. Don't worry about that at all. You can buy it from wherever you want, and there's lots of other books out there as well if you want to go looking for those. Our grade, similar to last semester, for those of you who know. So I have changed our homework, so they're 35% of your grade. Labs, about 20 of them get graded. We'll have some optional labs that will replace your lowest grades, but about 20 of these things in the end will get graded. And then our 6 quizzes plus 2 practice quizzes, like always. So a practice quiz before the midterm and a practice quiz before the final. And so your midterm and final exam grades are a little bit big piece of your grade, right? So about 50% of your grade. Okay, so a little bit more pressure on those than before. But as always, the pre-work kind of helps you on that stuff. Okay, so hopefully that'll help you get ready. So, okay, homework due Tuesday. This is the usual stuff submitted through Canvas. Now, because we're doing multi-file submissions, So I will absolutely support people who want to upload files, but in some cases you may be uploading 10 or 15 files every time. So that's why I kind of try to find a solution like Program IZ or Replit, because it just saves you a lot of headaches. Because if you forget a file and it doesn't compile, or you've got something out of date, it's kind of a nightmare. So so you can do it, but I'll warn you ahead of time, when we get to like a lot of multi-part submissions, it gets a little bit squirrely. So you got to be really careful pasting code in. So probably I'll only allow file uploads, no pasted code for homework assignments, or submitted through a link. And this is really pretty similar to what we did last time in some of my other courses. So most of our homeworks are going to be games, not a lot of graphics, just sort of text. But we're gonna do legit games, right? That are a lot more intense in terms of data structures and sort of modeling. So they'll kind of challenge our ability to break down a problem and build something up. Homework late policy, remember, 10% per day, goes to 0 after Sunday midnight. So try not to kind of fall into that category. You get to drop 1 homework. So out of 8 homeworks, we'll drop your lowest grade. So if you have a bad 2-week cycle, that's okay. It's not the end of the world, but save that for when things get really rough later in the semester, okay? Quizzes are due every Tuesday night, 10 to 20 questions like usual, 3 tries. So you can always push your grade up. Might have some 4 tries on the harder stuff, but most of the time it's 3 tries. So please try not to be late with those, because we don't have a late policy for that. So because I can't manage to grade all that stuff if it starts piling up. So apologies for having to be strict on that. Midterm is going to be about right before spring break, as always. Open book, closed to humans and no AI, and all of that stuff you've seen before. Fill in the blank, couple essay questions, multiple choice, typical stuff. Same for the final, not too much different. You guys have seen that in many of my classes. So we'll once again have our Tuesday, May 20th, 6:10 class. I'll remind you that when we get closer to that, okay? So our lectures will go till about 7, and then I might go a little bit long, but you're welcome to walk out and take a break and come back in. But by 7:10, we'll be in lab. It varies, of course, but please be trying to work along with us in class. I know today's a lot of talking, but we'll jump into coding pretty aggressively starting on Thursday. So please be ready to code when you come in, and come and go as you need with lab time. I'm not going to grade you on your attendance, as I've always said. So this is from COVID. I will be on Zoom for lab time regardless of who shows up. Sorry, that's got to go. I got to pull that out of there. So apologies for that. Labs are available the Monday morning of each week. Even though usually you're going to need some information from class, you're welcome to jump on them as soon as they become available. Okay, so if you like getting ahead of things, feel free. You're welcome to do that as long as we get them by midnight on Friday. Okay. All right, just a couple reminders about C++. We'll refer to it as C11, C++11. That's when it was validated in 2011, which seems like a really long time ago, but it's actually still pretty modern. And there's been just a little dribs and drabs of things that have come out that have to do with threading, and there's some new concepts, but not a ton for us. The big one that we're all waiting for is the one from 2020 that will simplify modules or multiple file development. Unfortunately, it's a little too early for me to be able to work it into our course, so we really are still going to be dealing with .h and .cpp files. So I'll explain that a little bit later, but this is one that companies will be moving to in the next 5 years, which I know seems crazy. It's 2024 and or 2025. We still haven't adopted that widely, but it'll happen in time. Okay. Or 2023 is the module. Sorry, I got that wrong. I was off by 1. Anyway, those are there if you want to read about them. So C++ is huge, very professional. People do complain about it, but man, it covers a lot of territory, and it is custom made for large development teams. So when I worked at Autodesk, it was like about 4 million lines of code, I think, in 3D Studio Max, a 3D modeler that we used at the time. So way more than any human can ever know, right? So you need to have very strict type management and tools for managing, putting together a lot of files together. So we'll experience some of that this semester, and we hope you can master these concepts before we get to the end. Quizlet, there is a special collection of Quizlets that will help you as things get more intense later on. Don't worry about it now, but just remember it's out there. So if you need a little extra help on terminology and syntax, you can kind of drill on this stuff, but it's purely optional for you if you don't feel like you need it. A couple quick things about Program IZ. There is an online compiler. Many of you have used this in some of my former classes. You don't have to sign up. You can just kind of like put some code down, make some changes. And when you share your code, that's when you get a dedicated URL that will save your changes. So it's a little bit backwards. It's not saved until you share the link. That's for the online compiler. And we'll use that for the first couple labs just to keep things light and easy, but we'll probably switch over to a more normal or replit kind of thing where we can have files, multiple files, data files, README files. The online compiler is just a quick one-off thing that lets us get into coding really fast and then get back out again. So we'll start playing around with that. And then we will soon see this cool new thing called the code visualizer. So it's up and running for Python. You're welcome to click into this link and watch what happens with recursion. If you never really understood how recursion was working, this thing's pretty cool because it will show you all of the versions of the factorial function in memory and how they're passing values down the stack and back up the stack. So many of you might remember recursion from our previous classes. So this tool that's being developed is pretty fun. It's like a debugger with a graphical thing on the side that shows you what's happening with your variables and your code execution. So we'll be using this in Python introductory class and C++ introductory class. You might find it helpful here too. They just don't have their C++ version out. We should have that next week. So it's kind of a fun exercise. They're really curious to know what we think about it. So if we end up playing around with it and we love it or hate it, we get to tell them and they'll make changes to the code for us. So that'll be kind of fun to do. Now for Program IZ Pro, this team version, if you see an email from me that says, you know, is it okay? And I've done this for some of you already. So since you responded already today, I've added you. So if you've responded, you know, earlier today, go check your Program IZ Pro account or check your email and click on that link, and it should add you in, and you should have access to like all of the tools, like everything they got, you should be available to you. So if you want to do that, jump in. I will check that in the morning when I get up and add everybody who's responded. I just need your permission to do it because it does use your school email. So, and again, it is optional, so don't feel like you have to do it. It just gives you kind of like Replit for free if you kind of know what Replit was like. So that will make things a little bit easier for you, I think. Okay. Now, of course, Replit is still out there. For those of you who don't know what it is, it's pretty good. It's really pretty good, but it's about 120 a year, I think. I don't know if anybody's heard any different lately. It's a little pricey. So nice tool to have if you have the money to spend on it, but we can't always do that. So you're more than welcome to still use that if that's your choice, okay? VS Code, I am still trying to get this room configured. So we don't have a C++ compiler configured for all of these machines, but we do have VS Code on all these machines. So if you want to work with VS Code at home, of course do that. I will try to get all these machines configured with C++ compilers so that you can do that in class as well. But I apologize this week, we are not fully configured, so we can't really use it in class just yet, but I am going to try to do that, okay? The problem or the challenge with VS Code, of course, is when you write something, it doesn't go into the cloud. So if you work on your code. Here, you gotta mail it to yourself or, set up some kind of way to capture your code and clean up your machine. So it is perfectly fine, but it's a little bit more work to kind of make it flow. But certainly you're welcome to use it, download it at home, and work with it anytime you like. Okay, and I'll try to get better at helping you with it. I'm not a super fluent Visual Studio Code person. And it makes it challenging because I'm on Mac at home. So I have to translate what I know to Windows whenever I work on it. So bear with me as I kind of get up to speed. Let me take a pause there, see if anybody has any questions before we introduce our first homework in our lab. Yes.
The quizzes,
Mhm.
are they gonna be mostly multiple choice, or is it gonna be also some like programming?
Mostly fill in the blank actually, but every quiz will have one or two essay questions toward the end. So I call them essay, but they're just programming questions. Like write a function that does X, or here's a class prototype, finish the class kind of thing. But they only should take about 5 or 10 minutes out of your 45-minute slot. So it's just keeping you coding. Yeah. Okay. Okay, let's talk about homework 1. So we've never really done any homework assignments like this before this class. This is a simulation, and it's in a very small way a physical simulation, but the code pattern is kind of different probably than anything you would have done in any of my classes anyway. And that's why I really like it for this class. It's object oriented, and it's graphical, but it also kind of challenges your maybe what you're familiar with in terms of how we do this. So you'll want to look at the code in Canvas, and there's some descriptions in Canvas on what we want. But in a nutshell, what we're trying to do is simulate a bouncing ball inside a rectangular grid. Now, we don't have a graphics card access that we can use really easily. So we're going to do it with characters like we always do. So we're going to have a grid of rows. So you need to make that leap of thinking of rows as your y-axis. So row 0 is at the top of your graph, and row n is at the bottom. So we count rows in the downward direction, and columns will go from left to right. So columns is the x-axis. So however you can wrap your head around that, that's what we're going to be doing. And you'll be printing out a new version of the grid every second. And we'll learn how to delay execution, so you can speed up or slow down your printing. And we're going to update the ball's position inside of the grid. So you're going to either have a dash for an empty spot or a B for the ball. And we're going to do baby physics, easy physics, right? But easily we can ramp that up and do a full physics system with this approach. And we're going to do it in an object-oriented way where we're going to have a ball class that you're going to write from scratch. And it's going to have a constructor, and it's going to have an update method that will update the position of the ball separately from a draw method that draws where the ball thinks it is on the grid. So the ball is going to draw both itself and the grid. So there's really no grid object in this homework assignment. There's just a ball object that imagines a grid and then draws where it thinks it is. Okay. So we are intentionally separating the draw method from the update method, okay? And sometimes this pattern is called model view controller. So we have a model of the ball, kind of the data attributes in the class. The view is the draw me, and the update is the control part. Okay, and so this is a very classic way to design simulation systems, model view control. Most user interfaces are actually designed this way. Browsers are designed this way. A lot of UIs and video games are designed this way. So we're going to just kind of explore this a little bit. So your ball class will have a constructor, a draw me method, an update method, and we'll have some really simple physics that we can actually work on. But let's kind of start by looking at a video of how this works if you don't pursue the bonus. So now we're dealing in a discrete environment where we don't have floating point numbers, right? We don't have a graphic system, unfortunately, where we can put the ball anywhere we want. So we're just going to do math that simplifies into the integer space. So our velocity for our ball is going to be 0, 1, or -1, or 0, -2, +2, right? We're not going to deal with moving the ball in the X or Y axis by anything other than an integer value. So that simplifies things right there. And then of course we just have an XY position, right? So our ball is going to have a velocity and a position, and we're going to update the screen, roughly once a second. And we want to update the velocity when we get to the edge of the grid. So if your ball ever disappears, that's kind of a bad thing, right? We want the ball to always be visible. And so we'll go through the math on this, but essentially our ball is updating its own position, and then our ball is going to up and redraw itself on the screen. So I've chosen a very specific situation here. You can see that we're in this kind of infinite repeating pattern where it's going to hit the exact corner. Whoops. Oh, that was the end of that video. Sorry. Where we hit the end of that the corner, and we do the same thing all over again, right? So let me just show you that one more time, and then we'll kind of move on. So that's how I know if your homework's working. If I start the ball in the upper left corner with a perfect square, then I'm going to, see it bounce on the bottom and come up to the upper top, right? But you could start it in the middle and have a different velocity for the X and Y, and now your ball is going to bounce all over the place like Pong, right? And that's really what we want to do. And you'll notice it kind of squishes at the bottom and scoots along. That's because we don't really have infinite resolution in our physics system here. So it's okay that it's going to scoot along the bottom because that's the best we can do. We can't really put it sort of between two spaces, okay? Sounds complicated. It's really not too bad. Now, if you want to do the bonus, whoops, let me go to the next slide. If you want to do the bonus and add a little gravity and bounciness, like how bouncy is my ball? Like, does it absorb all the energy and reflect it back, or does it kind of like sort of squish and slow down, right? And is there gravity so that every time it tries to go up, gravity drags it down? So this is kind of what you get if you augment the math just a little bit. And now we're entering the realm of sort of game physics, right? And many of you might have thought about this before. It's actually kind of simpler than you think once you get it going. So you can see that at the end there, the gravity just took over and sort of the ball just stopped bouncing altogether, even though my simulation is still going. My velocity ended up being 0, my position's in the lower left corner, etc. Okay. So what I love about this stuff is it's just like every time you add a little thing, there's something else you can add. It's like, oh, now I can add obstacles. Now I can do this, right? And this is how game physics systems are born. So this is going to be our first homework assignment. You don't need to do the bonus. It's not a lot of extra points, but a lot of people get, kind of excited about the prospect of doing gravity. But let's just review what we should be thinking about in terms of the grid. So the ball knows where the ball is located at all times. So that means the data, the attribute for the class needs a integer location. What row am I on, right? So this is our row 0 up here, right? In our imaginary grid, and our column 0. So that's my XY location, right? So the row is Y, if you want to think of it that way, right? The column is X. So I'm immediately challenging your understanding of rows and columns at X's and Y's, okay? But rows increase as we go down, right? And then columns increase as we go to the right. Okay, and that's the way we're going to kind of do that for this particular assignment, okay? So if you have a positive X velocity, the next time you do a loop and update your ball's location, it should move to the right. And separately, fortunately, in the Cartesian space, the Y can be handled with a separate addition, right? So we add a position to the Y based on its velocity. Okay, so we're always just adding the velocity of X to the X position and the velocity Y to the Y position inside of the ball's class data attributes. And you'll see how this code lays out here roughly in a second. Okay, so if we just put that inside of a loop and we draw where the ball is every time, and we come up with a way to draw the grid, at some point our ball is going to exceed our imaginary final row. So if we agree ahead of time, we're only going to have 10 rows, then when the ball gets into the final row, we have to reverse its velocity in the Y direction, okay? So the reason this is a great first assignment is you're going to be doing the good old, like, am I in the bottom row? Now what do I do to the velocity? And your ball should never disappear from the screen, right? And once you get it, it's really fun. It's like, oh, wow, I've got a simulation going, right? So if we reverse the velocity, right? If we don't reverse the velocity, we're going to go off the screen. So if we detect that we're going off the screen, we kind of got to push that B up, right? That's kind of our bounce. We got to make sure to update its positions in case it went too far. And this happens in real game physics as well. Stuff, it's called the bullet through paper problem. It's like somehow the bee gets on the other side of the wall and we got to like push it back into play. And then we start our looping again, right? After we fix our location and our velocity, we've inverted that. And now we just keep going until our ball kind of violates some other boundary rule, okay? So the corners are messy, right? Because you kind of got two violations you got to watch for there, but you guys will figure it out. It's fun. Once your ball starts bouncing around and going off the screen, you start patching holes, and eventually you've got yourself a physics simulation, okay? So that's the basic idea of this thing. And the update is really what's going to take care of all that stuff. Let me get this thing out of my way. Video panel. Nope, not that one. Hide the floating panel. There we go. So that's our update method inside of our ball class. Okay. And our ball class is going to look like every C++ class. We're going to have private data members, and then we're going to have our constructor. We're going to have a draw method and an update method. Okay. And in main, we will create an instance of the ball, and then we'll just loop and loop and loop, and we'll update the position and then draw it and update the position and draw it. And there'll just be an infinite loop running our simulation, okay? But that's essentially what we got to do. So the README and the Canvas stuff will remind you there's no grid class. The ball kind of imagines what the grid class is. So its data members need to know how big is the grid, how many rows, how many columns. So you'll see that in the README. So I've kind of just left out some of the extra details. But the ball remembers how big the grid is. So our constructor for the ball, we have to give it initial location, initial velocity, and how many rows and how many columns. That's the information we got to give our ball so that it can run its simulation. Okay. So all of those are going to be our data members initialized by our constructor class, okay? Now, if you want to go beyond, you can increase the grid dimensions as big as you want, right? As big as you can fit on the screen, just sort of make your math bigger, right? More rows, more columns, more resolution. Now you can kind of see your ball going farther and doing different things, right? Now, we can switch our velocity and our location to floating point or double. This is kind of extra challenging. It's pretty cool if you like math and dealing with these kind of problems, but you got to remember to truncate that to an integer position because we don't have a really great graphic system here. So for those of you who want to take this on, I fully support you. Just let me know if you run into any problems with that. We can kind of work things out. But for the rest of us, integer space is probably the best way to get started. I'd say for sure, get it going in integer space first if you're thinking about switching it over. And if you want to do obstacles, let me know. We can do that too. There's all sorts of things we can do with obstacles. But this is kind of how I got started in graphics. I started doing particle systems, little 2D physics systems and stuff like that. And I just learned so much. So hopefully you guys have fun with it. So scoring rubric like we usually do. Well, there'll be 5 points for code and comments. The ball class itself is about 70 points, right? Just getting that right. And main is about, I think, 25 points in total. And then you can get an extra 5 on the bonus if you want to pursue the gravity and the elastic balance, okay? So it's not a lot of code. Hopefully it's fun. You might want to start on that, sometime this week. You should know everything you need to know to start the ball class. We're going to do it all in the main.cpp file, okay? So you don't need to separate this into separate files for this assignment. So hopefully that will simplify our start, okay? So that is homework 1. Sorry, I kind of wanted to get that out in front of you so you knew, what your runway looks like. And our lab for today is not a challenging one at all. We're just trying to exercise our memory about how to write a function that calculates the average of a large array of numbers, okay? So this is not due till Friday, but essentially what we're trying to do here is just start with some code. You'll see that I have prototypes. Remember that we're going to put our prototypes at the top of our code file. This is kind of our blueprints, right? We don't want to change that. And then we will kind of just call our function to fill the array. Remember that in C++, the array is passed by reference. So we don't even have a return value, right? We pass the array in. Our function that I will write for you will fill that up. And then you will call your function to find the average, okay? Nothing too tricky, but if you're like me, I didn't do a lot of coding over the holidays and things might be a little rusty, okay? But we want you to write your code down here to implement this find average function down here and then call your function here, right? Or call it here rather, and then print it out here. You can kind of see I'm already calling my function that I've already written for you, okay? So you don't have to write the fill array function at all. Okay, so I've got a replit link here, but if you go to Canvas, there's also a Program IZ Pro link, right? Or again, if you want to submit a file from anywhere else, that's your main.cpp, feel free to go ahead and do that. But take a look at Canvas. You'll see these links come up over there. So let me see that. I know this won't come up on the screen, but if I go over here and I click on Program IZ, just a couple quick reminders. So this is the free version. This is the online compiler. So if you've not seen this before, it's kind of like Replit, but it's an ad-based model. So we have to endure the ads. You know, if we haven't finished our code, it's not going to do anything interesting. So we kind of come in here and we write. So here's my function. You're going to implement your function down here. Remember, with the online compiler, even though you see this URL here, after you make changes, you have to share to get a link. And now this is what you submit, right? So that's going to go into Canvas for your submission for your lab once you've finished all your code, okay? So it's a little different than other systems. You really don't have any saving until you share. That's the point at which you've actually saved your work, okay? So once we adopt, you know, the Pro version or Replit or Visual Studio Pro, you can kind of move away from this sharing thing. But for this one, I think you can kind of write this once and do a quick share and be done with it. So that is the Program IZ online compiler approach. Hopefully that keeps things really simple for you. And that link is in Canvas, or you can use the Replit link you see right here, which is also in Canvas. So hopefully that just gives everybody kind of options to do stuff the way they prefer, okay? And let me see, and I think that's it. So we'll kind of let you guys kind of do what you got to do. I'll answer questions and deal with any of the ad code stuff, but looking forward to the semester. This is a really fun class. I think we had a really great group of folks here, so glad you're here. Let me know if you have any questions. And again, please respond if you want me to add you to this pro team. You can think about it, but if you think of it and you want it, just send me an email, say, yeah, please, and then I'll do it. So, okay. Any final questions before we go? All right. Thanks, everybody. Have a great first week, and I will see you on Thursday. Thank you. Stop. Yes.